Hello friends, welcome to my channel. Today I will be discussing Leetcode combination sum problem. First, let's read the problem. It's a medium level problem. Given an array of distinct integers, candidates, and a target integer target, return a list of all unique combinations of candidates. The chosen number sum to target. You may return the combination in any order. The same number may be chosen for the candidates an unlimited number of times. Means that the same number can be chosen an unlimited number of times. हम उसको कितनी बार भी choose कर सकते हैं. Two combinations are unique if the frequency of at least one of the chosen number is different. Okay. It is guaranteed that the number of unique combination that sum to target is less than the 150 combination of the given input. Means that the unique combination that we can get is less than the 150 combination. And input is given as, I have noted this in the one notebook. So let's go to one notebook. So in this we have to return the vector which contains the numbers which sum up to the number 7, and in this we can use the number any number of times. Okay, so see we can use the number any number of times. Let's take that one. Okay, so to do this question we will use recursion. We know that we can either pick an element of the index of a particular index, or we can not pick the element of the current index. So my approach will be that I will use an equation, and I will use the approach that either I will pick the element or I will not pick the element. So firstly we should use recursion, a function, and it will first contain the index. So the index will start from 0. Okay, and now our target is given to us is 7. Okay, and see, and we will maintain a vector of vector int which contains the number which sum up to the particular target. So see, I will come to the first index and see, and I will either add the element at the current index, or I will ignore the element at the current index. So see, I'm now on the left hand side I am adding the element at the current index. So it will be function of, if you will add, so it will be I will add the element at the current index, so 0, because we can add the element at the current index any number of times. So 7 minus 2, which is equal to 5. Our target will be reduced by the element at 0 index, so 7 minus 2 is 5, and our data structure will contain 1 because we have added this number and on the vector int. And on the left hand side we will ignore the number on the array of 0, and we will jump to another index which is plus 1, which is one other index. So f of 1, and target will remain same because we have not included this number, and our data structure will be empty now. Okay, let's trace the recursion for the left part. Okay, in the left part I have said that we will include the number at the 0th index. So 2 will be again included, so it is f of 0 I could, because we can add the element any number of times, and 5 minus 2, because array of 0 is 2, so 5 minus 2 is 3. Okay, and the data structure will contain, presently previously it was containing 2, so now it will also contain one more 2. Okay, and now on the right hand part I am saying that I will not include the element at the particular index. So I will ignore the element at the 0th index, and I will go to the first index, which is index plus 1. So it will go 1, and the target will not be modified because I have not added the element, and the data structure will contain 2. You see, now I will trace the left hand part again. So on the left hand side I am saying that I will be including the element. So we can see that if f of 0 will remain as it is, and 3 minus array of 0, which is 3 minus 2, which is equal to 1, and 2 will be included 3 times on the data structure, 2, 2 and 2. Okay, and on the right hand side I can see that I am not including the element, so it will be f of, I am jumping to the next index, which is 1, and I'm not changing the target value because I am not included the element, so it will remain as it is. It will 3, and 2, 2. Okay, our data structure will remain as it is because we have not included the element. Now we'll trace from the this inside, and we'll check whether our element, when we will maintain a condition that whether the target, it's our target, is greater than equal to array of index. This condition I will maintain. This condition I will maintain so that I could only include the element which are less than equal to target. And if you will see that we have our target less is 1 and the array at index 0 is 2, you can see that the array of element at array of index is 2, which is greater than the target, so it will not be included and it will return back to the recursion call. So recursion call will not be processed of on the further side and it will return back to previous. Now let's trace for the third. We can see that in the left hand side we will be including at the element at first index, so it will be okay, f of 1, and our target will be reduced by 3 minus array of 1, which array of 1 is 3, so it will be 0, and our data structure will contain 2, 2 and 3. Okay, and now right hand side will not include the element at the array of 1 and will jump to next index, which is 2, so 2, our target value remain as it is, and our data structure will contain only 2, 2, which was included previously. See, okay, now you can see that the target value is 0, and if the target value at any time we get the 0 and our data structure contain the element, then we will not further process the iteration because it will be useless, as because either the element that we will be choosing is always greater than equal to 0, greater than 0, so it's not for a cause to go further in the recursion, and we will trace back. So we will trace back here, and in the left hand side let's trace the recursion. So you can see that the element at 2, we have on the left hand side we will include the element at the second index, so 0, 1, 2, and you can see that it's 6, and our target is 3, so it will not be included because 6 is greater than the target, so this recursion call will not be processed. And if you will not include, then it will be f of, and we have gone here 2 and it will be 3, and some target will be equal to same only 2 and 2 and 2. Okay, now we'll process its left function call. We can see that array of 3, 0, 1, 2, 3 is 7 and it's greater than equal to target, and it's greater than target, so it will not be processed further, so it will return back like here, it will return back here. Okay, now if now we can't make the left call and it will return back, and if you will further process, then it will be equal to size and it will be returned back, so this will be returned back, and we have got our answer here, so it will be true, it will be an answer which will be pushed back into the answer. So I have processed this left hand side call. Let me process the right hand side call so it would be more clear to you. Okay, let me erase some part which is not useful. You see, I processed the left hand side call of this, and we have got one answer which is 223. Answer was 223. Let me process this right function call and it will be more clear to you. So in the left function call we will be including the element at array of index, sorry, so it will remain as it is, and it will the target will be decremented by the value of at array of index 0, 1, it is 3, so the target will be decreased by 3, so 5 minus 3 is 2. Okay, and we have included the element which is 3. On the left and right hand side, we are not including the element at the index, and we are jumping to the index plus 1. So it will be 2 and 2, and the data set will contain only 2. Okay, so see, on the left hand side, we will be including the element at the array of index. So it will be array of 1 and 2 minus array of 0 1. So we can see that it's 3 and it's greater than or equal to target, and I have showed you that our target should be always greater than or equal to index. So this function call will not be processed and it will be returned back. And now let's trace the right function call. They are saying that we are at an array of index and we have to include the element at the second index. So 0 1 2, which contains 6 and it's greater than target. So this function call will not be processed, and if you will go to the right hand side, it will not be including the element at the second index, and will go to the third index, and the target will be same 2, and the data structure will contain 2 only. And if you will go on the left hand side, it will contain, say that I will include the element at the array of index 3, and but you can see that 0 1 2 3, which is 7, and you can see that 7 is greater than, so it will not be processed further. And if you will go, then you have reached the size, and which is the break condition of our loop. So, and the target is not 0, so it will not be included in our answer. So here the function call will return back, and this also will return back, and this also return back, and so this will return back, and we have said that I have not got any answer, and we have got from the left function called the answer. So the approach is simple here, and I think it would have been clear to you when I was solving the example. So let's get to the coding part, and I will explain the code side by side to you. So see, okay, see, I have said that first we will maintain a vector int of answer, okay, to trace our answer here, and we will maintain a data structure ds, and we will maintain ds data structure, which is used to contain the vector of numbers which sum up to the target, and we will start from our first index, and we are passing the function parameters candidate, target, ds, and answer, and we will check whether the index equal to array of size, whether we have reached the last index, and it will not be useful to go other than the last index, and it will cause overflow, array overflow. And if we'll check if target equal to 0, yes, we have found the target is 0, and we'll push back the current elements which are existing in the ds, means the vector we have found which contains the number which sum out to the target, okay. And if the condition is false, then we will return. If the target is not equal to 0 and we have found the last index, then also it will return. And for including the element into the data structure, we will first check whether the element at index is less than target. If the element is less than target, then only we will include in our data structure ds by including index, and we can include element as many times as it is possible. So I have said that int and array, and we are reducing the target value with the array of index value, and we are sending the function parameters. And after the function call was processed, then we have to remove the element which was pushed back, so that we could further process the other function calls. And at last, if we are not including the element, this function call will possess, so that we have to ds dot pop back, we have to remove the element which was pushed, and then we have to get on the iteration of the second of the other index element. That's why I'm using ds dot pop back. So let's run the code, submit it. Thank you friends. If you like this solution useful, then you can like, share, and subscribe to my channel. And also please friends, subscribe to my channel. And also if you have any doubts, then please leave them in the comment section. I will try to answer each of them